Okay, which problem are you at now, Mr. Judge?
Number checker.
Number checker. What is the problem there? Number checker.
Oh, I got an idea. Alamak.
Number checker. So the problem is the input can be word or number. If it's a number, you need to double it. But if it's a word, you need to capitalize it.
97 minus 65. 32. 32, yeah.
If
Okay.
you already have two upper, why don't you just use two upper ones?
That's what I did.
Does it not work?
I don't know. This is what I get.
What is SI? Oh, two upper. Okay, is that the correct function? What is the input of two upper? C++ two upper coba. Two upper expect string, mas. Not char.
Really? Oh. Yeah. Yes. Two upper. Yes. This is Arab.
Doesn't work?
No.
For a string. Okay, it was string just now.
A string.
Two underscore upper.
Oh. Two upper.
Doesn't work? Is it? Do you really need to do one by one? Oh wow.
Two.
Yeah, in that case, you revert that again, but you just need to convert it to character char. Just now in your code, because it's integer, right? See, two upper is actually converting it to integer, so you need to convert it back to char.
How do you mean convert it to integer?
No, two upper returns integer. You see the definition on the top, on the top, on top, on the top. Yeah, two int, two upper int. So it returns integer. That's why you need to convert it to char. You need to cast it to char.
Oh.
So your C out itu you need to make it char. Yeah. CHR I think. CHR. Oh, char only bisa ya. Coba. Oke, coba. Does it work? Yeah.
Okay. Yay.
Okay, that's easy. So, okay, now coba scroll down. Some of the easy problems. You see there is one dynamic programming. You want to try dynamic programming?
This one, I don't know. I already see this and I don't know.
Yeah, explain the problem.
Well, there is a board, right? And it has numbers on it. And Bradley has to enter from one of the tiles of the board, which is from one of the integers, and exit from another. Then what is the minimum sum of the integers that Bradley can obtain that she went over? Like this, you go -7 and then 3 and then -5 and then exit.
What is that? Oh, I see. How do you exit?
From any other integer.
Gimana? I don't get it.
So
Start from any integer and can finish exit from any integer.
yeah.
Ah, then why is the answer -9?
New one.
Oh, so but he has to take everything, yeah, everything to the right.
No, no.
Oh. Huh? If it is like that, then you can just sum from the right, right? Are you
No,
sure?
not it's not from the right. Can do from anything and go up from anywhere. Really?
At one point in the game, Bradley has to step on one of the integers on the board, optionally travel right over a few integers before getting off the board at a
Yes,
certain integer.
it's any.
Okay.
Travel right. So it actually doesn't
Yeah,
matter.
yeah.
Doesn't matter for even if you do like this, you can still travel right.
So ini similar to remember yang longest increasing subsequence.
Yeah.
So in longest increasing subsequence, you need to find a subsequence yang contiguous, right? So you have like keep track, right? You have to keep track up until that point, kind of, right? So then this is also the same thing, right? You need to like keep track. Yeah, let's say you keep track up until that point. What is the best? What is the best? This mean is contiguous, right? Yeah.
Yeah.
So let's say up until the first one, up until number 2. If you exit from number 2, what is the best number you can get? 2,
2.
right? Yeah. If you exit from the second one, -3, what is the best number that you can get?
Minus 3.
Yeah, -3. Yeah, like that lah. You get what I mean? Yeah. So the next best yang let's say you want to exit at number 4, what is the best to start at to exit at number 4? That means you added yang -3 kan? So you continued from -3. If you have to exit at number 4, then you should have continued from -3, right? So you got -3 and 4, you got the best is 1. Right? That's the idea.
But
Get what I mean?
no. But how do you know it's a minimum?
Because if you want to exit at 4, right? That means your option is you continued from some number before 4, which is -3, right? You continued from there. Instead of exiting at -3, you continued one step to 4, right? And then exit at 4. That means the best exit, if you have to exit at 4, right, is what is the minimum between 4 itself and 4 plus the previous one, right? You get the logic?
No.
Okay, how do I do this? Yeah. So let me share my screen. Hold on, yeah. Okay, so let's say what are the inputs just now?
8, 2 minus 3, 4 minus 5, 6 minus 7, 3 minus 5.
2 minus 3, 4 minus 5.
6 minus 7, 3 minus 5.
6 minus 7, 3 minus 5. Ini ya. So that's the input, right? Hold on, let me just open that also step here. Okay, so now first step, right? If I have to exit, okay, let me just put a number here, yeah. So this is 0, 1, 2, 3, 4, 5, 6, 7, right? So if I have to exit at 0, if I have to exit at, right, 0, that is 2, right?
Yeah.
Now if I have to exit at 1, that means my choice is either I start from 1 and exit at 1, which means is apa?
3 minus 3.
Minus 3, right? So start 1, exit 1, ya kan? Or I can also apa? I continued from, right? Continued from before, kan? From my left, right? Which means I continued from 0. Continued from 0, exit 1, right? Which means apa? What is that? If I continued from 0, that means
Exit 1, then it's minus 1.
It is equal to what is the best at 0 plus number at 1, right?
So it's minus.
Is what? 2?
It's 1. Minus 3.
Yeah, 2 plus minus 3, right? Minus 1. So my option is either minus 3 or minus 1. But which one is best?
Minus 3.
Minus 3. So this is like this. So it's minimum of these two, right? Minimum of these two. You get what I mean?
Yeah, I get it.
Then you continue, right? So this is called dynamic programming because your logic kind of your decision change dynamically based on other state or position gitu. So based on zeroth result, then you decide on 1, and based on 1 you decide on 2, based on 2 you decide on 3, begitu. That's why it's I think that's the reason why it's called dynamic. Okay, so now continue coba. Okay, I'll copy paste this to the chat.
Wow.
Coba you continue, you copy paste at the chat. Oh, wrong place. Should have used private chat. Okay. Yeah, you copy paste to your. Yeah, coba. Coba you continue. Continue what I did just now, just to make sure that you actually understand the logic.
Okay.
Okay, so next continue coba.
Okay.
Yeah, continue the logic coba. So at 2, what is this?
At 2, at 2 it can be 4. 4 on. What do you mean? Why do you need my phone? In my bag. Let's bring the bag to Bunda building. Okay, 4. 4 or.
4 or what?
Oh, wait, why do I have to look at 4 or minus 3
Plus?
plus 4. Plus 4, yeah, is it right?
Yeah.
4 minus 3 plus 4, which is 1. So it's 1.
Yeah, it's 1. Yeah.
And then after that, minus 5 for minus 5. Okay. 3 minus 5 or minus 5 plus the smallest plus minus 3 plus
No,
1.
no, you cannot. Has to be your previous ini kan board, right? The best in your previous board. You cannot go behind already. You cannot. You cannot jump, right? You don't
Oh,
even look at -3 anymore. It's already past.
oh, because it's already here.
Yeah, you are now at, you want to exit at 3. That means your option is you start from 3 and exit at 3, or you actually continued from 2 and then only exit from 3. Gitu.
Oh. Okay, then this one number 4 is 6 or 6 plus minus 5 is equal to 1. So it's 1. And then 5, it's minus 7 or minus 7 plus 1, which is equals to minus 6. So minus 7. Uh, 3 or 3 plus minus 7, which is equals to minus 4. So it's minus 4. And then it's minus 5 or minus 5 plus 3, which is equals to minus 2.
Kok 3?
Plus minus 4, which is equals to minus 9. So it is minus 9.
Yeah, right. So how do you find the answer now?
Get the minimum of all
Very
this.
good. Yeah, which is
Minus 9.
9.
Oh,
Oh, okay. Now time to implement. You get the idea, right?
yes.
It's a simple dynamic programming. So it's like you have a state, you have a apa? Yeah, state. See, this is called state.
Yeah.
And in this case, the state is what if you exit from that integer, exit at that integer. Yeah.
And 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 then we input and we get previous one. So there is prev, no, previous, and current. And for int I 0 plus smaller than n, I plus plus. So we get this. No, I get this. And then I see current, get the current, and then I check. Oh, previous have to be equal to 1. And then ans I equals to the minimum of current, and the current plus prev. Okay. Is like that. Then two. And then the next one, I get minus 3 for the current. Oh, then the rev equals to current. Previous is the current. No, 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 no. Rev equals to mean current plus rev. Wait, yeah. A, then that's and then I get the minimum of the array. Uh, I equals 0, I smaller than n, I plus plus, is in, oof, smallest, smallest equals to in
In max, yeah.
max,
Underscore max.
in max. I don't
Yeah.
think so.
And do it that way, yeah.
And then if r no and I smaller than smallest equals to and I. Count smallest and then
Coba tes.
marvelous, marvelous,
Good. Good, good, good.
marvelous. This is a very marvelous. Wow. Yeah.
C limits.
Wow.
Fantastic. Jelas. Just dulu. We'll see.
Sh-
Ah, nice.
Bravo, bravo,
Yeah, yeah. Bravo, bravo, bravo.
bravo, bravo. Chinese basic binary marker. Johnny changer.
Okay, another dynamic programming. Money changer.
And when she realized how earning she had to give about 20 coins to a customer solution. And there was a little her make a value that she could just refuse. That requires her to select too many coins. Unfortunately, given n coins where given n coins where and each coin has a value ni, one is r and a value v is also an integer. Calculate the minimum number of coins needed to make v with the n coins provided. Sample input. I want the n and v. Yeah. With the I plus 1 line representing the value ni. 0 plus 1. No, if it's 1.
So there are six types of coins gitu kan. $1, $2, $5, $10, 25, 50. And then to make 99, you need 6 coins.
50. Oh, this is just like before.
Yeah.
Wait, does it have to be exactly?
Okay, if it is impossible, output -1 too. So it's possible for the problem to be impossible.
Okay, this is hard.
Not really, right? Actually, you can solve this even without dynamic programming. I'm now thinking, how do we solve this using dynamic programming? Yeah, why do they categorize this as dynamic programming? Yeah.
I wanna try without the programming.
Just to. Meanwhile,
Maybe
let me find another dynamic programming that could be useful.
there will be two integers and b
3.5.
b then b that will be get int prices and for int I equals 0 price and I plus int prices dot prices prices plus n greater int bracket and include algorithm. When I set it differently, while when it
While apa?
while n greater than zero.
Zero.
Hmm. While n is greater than zero. No, while v is greater than zero. V is greater than zero. And then we get an integer coins for zero. If v greater than prices I a equals zero a
Okay.
v mm, v equals v minus v modulo prices a and then we divide by prices a. Okay, something like this. No. Uh, Points plus equal and then v have to v equal v modulo prices a.
Yeah, you can use modulo equal.
Oh,
Yeah, same thing, right?
and a plus. But if it's not a plus,
Which means it's a plus plus anyway. Yeah.
um, but then now I have to check for an error. If it's
Yeah.
error, then that means it's impossible.
Yeah.
So how do I check if there's an error?
So in what situation?
When v when there's no coins to to fit the rest of V.
Yeah, which means that means in your current logic, what will happen if you are given an input like that? What will happen to your code now? What will happen in your code?
It will be out of bound.
Out of bound, right?
Hmm.
How do you make sure it's not out of bound?
And A greater than no A smaller than prices. No A smaller than N. Is it?
Good. Yep.
Yeah. And then if
Alternatively, you could just do for loop on prices. But same
yeah,
thing.
you can. I like what you. Then we check A if A is 10, yield
Okay. There is a bug in your logic, but I will let you figure out yourself. Ya. You try aja dulu. There is a bug somewhere in your code, but I'll let you figure out yourself.
mm, okay, then how when we play else uh, if coins greater than how many what's the maximum it was when she had to give about 20 coins to customer. I think it is the minimum if it is impossible to meet. Oh, okay, okay. Else, yeah, coins. And then, wow, amazing. Let's
There
see
is
if
a
there's
bug
some.
somewhere. Ya. It's okay.
Huh?
There are two bugs actually, but it's okay. Submit dulu aja. You will hit the
Oh,
wrong answer, a couple of wrong answers.
what?
A lot of wrong answers. You're only correct in a few.
Okay,
Okay, now time for you to find the bug.
okay. Bug. No! Why? I don't understand.
Okay, I'll give you test case. 3,
See?
let's say 8, and then enter.
Oh,
You found a bug already? What are you doing?
apa? What is that then?
3, 5. Sorry, not 3, 5. Sorry, 3, 4, 1. Hmm? Kok 2 sih?
Is
Ingat
it not
lah. How do you make 8 from 2?
4 and 4?
Oh yeah, sorry. Then I put the wrong one. Use 5, change 4 to 5, and 8 to 9. Okay.
Huh? 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 Eh? 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 And A is smaller than
That's one out
N.
of one of the two bugs that you have.
While if V greater than the prices of A, coins plus coins will equal to V minus 4. That's 1. It's 1. Oh, okay. Let's see. If V is 0, we add coins. Else minus 1. V
Hmm?
V minus equal prices A multiplied by
No. That's correct already. You don't need to do that. That's correct. Modulo equal udah correct. Ya, coba follow the logic aja one by one. If you put in 3 sama 9, what happens?
9 is still greater than 0, and then 9 is still greater than 1, and then 5, and then coins plus 1, and V will become 4, and then A will increase, and then and then more prices A is 3, and then 9, we check, if V, now it's 4, right? So if V, so, so it's 4 is greater than 3, 4 is greater than 3, then that means coins will plus 1, and V will become 1, and A increase, then will become 1. Then V is still greater than 0, so it's 1.
Yeah, how come your code?
Ah,
Can you?
ah,
Can,
ah,
hmm?
ah, 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 ah,
Yeah, that's
ah.
your second bug. But actually, okay. How come this affect this test case? Because
Affect
your
what?
last iteration you get
It's 1.
1. Okay.
It's equal. Now, what's the second bug?
No, that is the second bug.
That was the first bug.
The first bug yang tadi ya, yang A equal to N tadi.
Oh,
A equal to N is the wrong logic. A can be equal to N, it's valid.
Maaf,
You use
saya
every single coin once. If you use
okay.
single coin, sorry, if you use the last coin, sorry. If you use the smallest coin, you will have A equal to N. Be a
Alright.
valid one.
Hmm.
Yeah, this doesn't really need dynamic programming, I think.
Maybe they want you to do it dynamically. Nani?
Oh, masih salah. Oh. Okay, let's see.
1,
You
2,
check
3,
the,
4.
can you check the integers, all the limits? No, I mean in the problem. What are the worst case?
Limit 10,000, 10,100. What's LE?
Less than. It's a bug lah. Less than or equal, sorry. LE, less than or equal. Uh,
Oh,
10,000 yeah. 10,000.
what if I change it to long long?
So what is the worst case scenario?
10,001.
You have
You have
you have
10,000.
100 coins. The value can be 10,000. How about the V? Oh, V is only 10,000. So it's not really a problem lah. V is only 10,000. Is small.
Or the values of the coins might not necessarily be less than the value of B. Oh, actually, doesn't matter.
Scroll up. We answered the problem correctly, yeah.
Hmm?
No, this is not like you have infinite number of denomination, right? You have exact set of coins. You cannot use multiple times.
Oh, what? Really?
Yeah. So yeah, it's not multiple times. So he really just plus 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 here.
Oh.
And it's not modulo then. Yeah. Okay. Then how come this is salah? Okay. Then how come it's like that? How come you now got wrong?
Greater in is descending. Yeah.
50 plus 25 plus 10 berapa?
Uh,
Se- 5.
75.
Oh. Sorry. So sorry. Can we look at the problem? I think we can do multiple times. Yeah. Can you look at the
Wait,
problem? The explanation. 6 coins are needed. Okay. See, it's used multiple times. Sorry. Yeah. Sorry. Can we use multiple times? Sorry. Okay.
mm,
So this one correct. So what went wrong? Yeah.
mm.
What could be wrong? Yeah. Minimum number of coins. Why do they say minimum? Yeah? Can you scroll up? Is there anything else in the problem that we don't know?
Yeah, or maybe like this. Maybe there, like, if the test case is 3, 9, and 3, and 4, and 1. No. 5 and 2.
Hmm. Oh yeah. Yeah. Okay. I know. Okay, let me
Then
think of a test case.
it's better is 3. Then 3 times. Actually, that I don't know lah. I don't know.
No, I know. Okay. Let me think of an example. Yeah. 10, 9, 1. Okay, you got 3 coins. You got 3 coins. So three. You start with three, three, right? 3 coins. Yeah, 10, 9, 1 is the coin. So three, and the number you want to make is 99. What do you get if you run your program? Okay, no wonder this is a dynamic programming.
Huh?
You got and hold
Is it
on,
not?
hold on. That's not what I wanted to do. Hold on. This is not a good example. Okay, increase. Tennya change to a. How do we do this? Oh, ini deh. Instead of 99, change to 9. Wait. Let me think. Um, 90. Okay, change 10 to 20. 10-nya change to 20. 99 change to 189. Nine-nya change. Okay. 189 change to 190. 190, and then 9-nya change to 10. Coba. You get 10. Okay.
Is that not correct?
Okay, sorry. Can you change your 10 to 19? Change your 10 to 19. Yeah. You know why it's wrong?
Ah. Hmm. No.
Okay, then this is a proper dynamic programming, Mas. Yes, this is a dynamic programming problem.
I still don't know how to do this. 180, 160.
You know what is the correct answer? What should be the expected output?
What? I don't know.
So if you have three types of coins, 20, 19, and 1, and you
Oh,
need
it's
to,
10. Supposed to be 10.
yeah, supposed to be 10. You know why you get 19?
Because it's 20 and then 1, 1, 1, 1, 1, 1, 1, 1, 1, 1.
Exactly.
Yeah, yeah. But how though? Why?
And this is a proper dynamic programming problem. To keep track,
No.
right? Now you need to keep track, right? Do I want to use this coin or not? That is the question, right? You need to, or or rather, you need to keep track. Yeah, whether adding this coin is a good idea or not. You need to find that relationship dulu. Yeah, this is a proper dynamic programming question. I think we need to wrap here. You think first. So and the idea you find the relationship basically. The idea of dynamic programming itu you need to find the relationship dulu. Just like recursive function kan, Fibonacci for example, right? Fibonacci, the relationship is Fibonacci of n is equal to Fibonacci of n minus 1 plus Fibonacci of n minus 2. So this you can implement using recursive, right? You do recursively.
Yeah.
But this is also what is considered dynamic programming because you can then, instead of doing it recursively, you just do from Fibonacci 0, right? Based on Fibonacci 0 and Fibonacci 1, then you can do Fibonacci 2. Then based on Fibonacci 1 and Fibonacci 2, you can do Fibonacci 3, and so on. You keep on doing that, right? Until you reach Fibonacci n. So it's a dynamic programming like that. But you need to find that relationship dulu, that formula, or yeah, how do you want to represent? Like, what is the relationship of the state? Nah, kalau yang tadi, yang apa step game tadi ya, the first problem we did earlier, the relationship is that the best number if I exit from here is equal to the best number if I exit from the number before me compared to my number, this number itself gitu kan. If I entered from here and exit compared to if I continued from my left, kan gitu kan.
Yeah.
So you find the relationship dulu. So what is this relationship of these coins? If you have so many coins to choose from, different unique coins to choose from, and then yeah, and then you need to figure out what is the best number of coins to use.
I have no idea how to do this.
Yeah,
It's
you need
two,
to find the relationship dulu.
it's
Yes.
two lines.
So what?
It's two lines.
No lah. Yeah, okay. Kita wrap up dulu. You think first, continue again maybe tonight or this evening. Let's find the relationship dulu ya, the dynamic programming relationship dulu.
I
Alright.
don't